So today we're going to talk about a very interesting question that has haunted America for as long as it's been around. How many squirrels would it take to power the USA? If you've been alive in the past 40 years, you probably know the phrase E equals MC squared. Some dude named Albert Einstein coined it, and he was supposed to be like really smart. Or maybe I'm thinking of his hair. I don't know. Anyway, let's look at the terms of the equation to see what's actually going on here. So E is the energy. It's the ability to do work like move a piston or put a rocket into space. Mass is how much stuff we have. And C is the speed of light, or the cosmic speed limit. So that little equals sign means these two sides are equivalent. Since the speed of light can be considered constant, if you have a little bit of mass, then you also have a certain amount of energy. Other way around, so if you have energy, then you can have a certain amount of mass. In theory, you could take something with mass and turn it 100% into energy. Something like maybe this squirrel. Careful, he bites. But don't worry, my little furry friend, we haven't figured out a way to turn 100% mass into energy. Closest thing that we have is nuclear fission, which is what the sun's doing. We haven't figured it out yet. But limitations are boring. What if we could transform 100% of the mass of a squirrel into energy? What could we power? A light bulb? A city? A nation? The world? We'll find out. Let's make a deal with the science devils and learn some maths. An eastern gray squirrel is about 1.09 pounds. But hey, wait, Mr. Four Eyes, you might be saying at home. Pounds aren't actually a measure of Pounds aren't actually a measure of mass. It's a measure of weight. Well, right you are. I was about to explain that weight and mass are actually related to each other by one other factor, gravity. So, if all of our calcs are done on the same Earth with the same gravity, we can just translate it into mass and the metric system. Sorry, not sorry. So a squirrel is about 1.09 pounds on Earth, or 0.494 kilograms. Next, all we need to know is the speed of light, and thank God we have all these scientists that can and already have figured it out. I sure wouldn't be able to do it myself. It's close to 300 million meters per second. God bless the internet. We take our fancy squirrel killing equation and plug in the variables. That's a lot of numbers, so I'm not going to read it out loud. Square the light speed term and multiply it to the mass term, and voila! So the units kilograms times meters squared over a second squared is actually the same thing as the unit of energy, joules. By the way, something to the 16th power is enormous. That's 4.4 followed by 16 zeros. It's freaking huge. So how many joules does it take to power a light bulb for 1 second? Luckily, we have a unit to describe joules per second. It's called the watt. A pretty standard light bulb uses 75 watts, or joules per second. So how many seconds can a squirrel power a light bulb? Well, just divide the energy of the squirrel by the power needed by the light bulb. Time equals our squirrel energy divided by our light bulb power. We get 5.9 times 10 to the 14 seconds, or actually 18 million years. Our squirrel can power a light bulb for 18 million years. So the US uses 3.9 terakilowatt hours per year, which translates to 3.3 times 10 to the 12 total watts on average. Divide the squirrel energy by USA's power usage, and we get 13,577 seconds, or about 37.7 hours. Think about that for a moment. One measly squirrel could, in theory, power the USA for over a day and a half. If we could Einstein our way to 100% mass to energy transfer, we could solve any energy crisis. So now I gotta figure out how to find my way back to Earth, because I don't know how I got in space. Anyways, see you guys later.